So moving on from cleaning to foreign bodies, Dan Baxter from Garrick will give us a presentation about foreign body avoidance and powder conveying and particulate feeding. A little bit background about Dan. Dan is the head of sales for Garrick. He is committed to providing clients with solutions that ensure their process plants run efficiently and provide a return on investment meeting the business needs. Having spent his early years with Chemotech Group, working in the R&D Center and completing a diploma in solids handling from North Trafford College, Dan has worked in a variety of process industries, including food, metal powders, pharmaceuticals, and chemicals. And this is his 27th year in powder processing. Today, he will talk about... Pardon?
Such a young face, too.
20, so we have to get you back in 3 years for your 30th. So as I said, today he will tell us more about the importance of eliminating foreign bodies and in the client's process and what simple steps can be followed to avoid costly product recalls. Over to you, Dan.
Okay, thank you very much. Good afternoon, everybody. So quickly, a little bit of an overview of who Garrick are. Garrick is a Swiss company. It's an engineering business, has been providing solutions for customers, complete system solutions, complete factory solutions for powder handling mainly since 1894. So this year is 127th year of existence. And in the UK, we have an office based just outside of Manchester, where we also provide complete factory solutions, but we also manufacture two types of machines. One of those is a sieving machine, which we will cover, of course, in this presentation. But in general, here is my presentation, and it is really to talk about simple steps and solutions that can be implemented within a factory to avoid product contamination from foreign bodies, low-cost solutions, which actually, for little investment, can protect a company from very high costs should a product recall be required. So when should a product be recalled?
I can't see your presentation.
You can't see my presentation. Okay, so as I was discussing, there are within the EC some legal requirements which are here listed on the screen, determining whether a food is fit for human consumption. And if that product doesn't meet the requirements, and there are a number of different areas that can be, whether that be quality, whether it be allergens within the product, mislabeling of the product, then a company is obliged to withdraw that product from the market, and obviously their costs will occur. So what are the common reasons for products being recalled? No doubt the highest reason for product recalls is for issues which Sebastian covered before about cleaning of a mixer, obviously things like some salmonella, listeria, E. coli. So not cleaning your equipment properly can cause big problems, and of course can cause bacterial growth, and this can transfer to the product. And then if the product has these in, this can cause people to be ill. And of course, then you will find out through the market for great embarrassment from the customer that you have to bring the product back in. And of course, that is why the previous presentation was very interesting, because it was talking about cleaning and the importance of cleaning. Now, the area I'm focusing on is contamination of product with foreign objects. So let's just have a look at a little bit of data here. This slide is showing us the total number of recalls from the US and the UK. Obviously America is a much bigger market, so it's no surprise that their figures are higher. But you can see from this chart where biological contamination is the highest. Labeling is a very common issue, obviously not having the correct ingredients listed, and for anybody who's in the UK at the moment, very sadly, but a good example of this is a major high street sandwich shop didn't have any labeling on their products. A young lady ate a sandwich from there, and unfortunately she had an anaphylactic shock and died because she wasn't aware of one of the minor ingredients in the product. So labeling is very important. But as I said, my focus is on foreign matter contamination, and you can see that in the UK, particularly, 27% of all food recalls in this instance were due to foreign matter being in the product. And if we just look at the food industry, typically, this is quite an interesting stat, just to look at how the different industries have product recalls around it. And we had a talk earlier on about dairy powders. So there's an interesting stat that 19% of all UK and 14% of all US recalls came from the dairy industry, and various other industries such as baked goods, bakeries, and confectionery is also quite a high area. So let's just look at some real numbers. There are various different figures out there, but I can give you in a second a real example from a client just 2 or 3 weeks ago. But this is an estimation that was put together by New Food magazine, where they looked at a number of factors. And of course, you have to consider things like transportation costs, the notification to the market, the fact that you have the actual material. So if you look down at the bottom, they give an example of an American company that had an E. coli break. They valued the product at 50 cents a pound. There was 10 million pounds of flour that they had to recover. So by the time you do the calculation, so the cost of the material plus the notifications plus the transportation costs, they estimate that that particular case cost $5.7 million to rectify. The US Grocery Association estimates that it typically a typical product recall will be somewhere between $1 and $10 million. To frighten anybody, they also said it is in one case cost $100 million, so can be quite expensive. Now, a few weeks ago, obviously I won't name the particular client, but I had a phone call from a client that had a problem upstream in the process. Some woven wire from a filtration process had got into the product. Fortunately, they did detect it downstream. They caught some in a magnet, and so they were able to detect that before it got into the process. But even internally within their own building before the product left, they estimated that it cost them £50,000 just to process that material, to clean up, to the cost of the raw material as well. So obviously, thinking about the right solutions and the capital investment, obviously, often it's, do we have the money to spend? But it's sometimes a case of, can you afford not to spend the money? Okay, so just some comments that I picked up off various different places. 50% of all consumers said they would switch brands if their product had foreign body in or had issues with microbiological contaminants. 20% would just avoid the full product range, and 15% said they would never buy from that particular brand or supplier again. So it can have a major impact on consumers' decisions. Okay, so let's talk about preventative actions. In many cases, and when we come on to look at some of the data in a minute, most incidents actually occur from inside the factory. Okay, so it's not that it's this is in terms of foreign bodies. We're now focusing specifically on foreign bodies. And very simply, some quite easy things that can be done. You can make sure that when staff are entering into the building, they're using the correct facilities, that they're changing in the right areas, that when they walk into the plant, they are using the correct washing facilities, making sure that boots are clean, making sure the hands are clean, hair is tied back inside of hairnets, gentlemen with beards are wearing a snood, and of course, things like jewelry is removed. Some companies will accept a plain wedding band, but don't like watches, they don't like earrings. So obviously these are very simple things that can end up in the product. And quite simply things like open wounds. You have to cover it with a plaster, of course. If you are going to do it, you can buy metal detectable blue plasters. And that's something that we'll come on to later in terms of things like gasket materials as well. And of course, you can do various other things, such as making sure that all the points are covered in general inductions for non-regular workers, visitors into the factory, metal detectable pens. There are many solutions that can be done at the very start of a process. Okay, one of the big things I've seen in the last few years is customers pushing on the machinery that's supplied to change and minimize the amount of plastic. Customers are very concerned about plastic because, as we'll see later on, it's not the easiest material to detect in a process. So where they can, they like to have things changed. So for example, stickers. A lot of customers now are saying, please don't put your logo sticker onto the machine, but you say, but we want people to know that we sold this machine. So, okay, if you're going to do it, please put it on a stainless steel plate. Don't put a plastic sticker on. Things like gland covers, bearing caps, anything that typically would have been made from plastic, even heavy duty plastic. Customers now prefer those to be all stainless steel. And when you have to use a gasket or cable ties, blue metal detectable is always the preferred option. This is interestingly a statement from Nestle to its suppliers, so I won't read everything out, but as you can see, they ask their suppliers to make sure that they are doing their bit in the prevention process. So they are making sure that where required, you have a first and a second and a third line of defense in the process. And first line of defense, very much making sure that the product is free, the packaging free from foreign bodies, so making sure that they, before they send those raw ingredients to Nestle, that they're separated, that they're processed safely before it goes into their Nestle's factories. Okay, so here is a very broad brush overview of a process plant. There are many different types of processes. You can have things like spray dryers, all sorts of different types of technology. You can't cover everything in one image. So here I just took a generic image that we use ourselves in our presentations to highlight some of the key areas. And what are we looking at? Where are the risks? Well, generally the risk is obviously anything that is being brought into the factory. So this may be from a bulk tanker delivering into silos. It may well be sacks that are being tipped into the process, big bags being tipped in, and of course, bringing those products into the factory. So these are kind of primary risks. And then also we have some sort of secondary risks as well. And these are more once the product is in the process, making sure that after they've been treated, just having some backup processes. We'll come on to the type of technologies that are available. And here I've just highlighted where we would generally put equipment into the process to protect, and simply building solutions. And building solutions can be creating a safe area between unloading a wagon and taking it into the factory. So you may have then an intermediate area where you then hold the material before you actually take it directly into the factory. This can stop vermin, even just things like leaves and flies coming into the factory. So it's quite a simple way of keeping the factory as sealed as possible. Okay, so what are we talking about in foreign bodies? Well, foreign bodies is anything that should not be in the material, not be in the final product. And they can be all sorts of things, whether it be live or dead insects. There are both can very much. And if anybody has had a bag of flour in the cupboard for too long, where they come from, who knows, but they can be flour weevils in your product. So if you have a bag of flour that you've not touched for a few years, go to the back of the cupboard, open it up. There's a good chance there'll be some weevils in that product. Very small, very tiny, but they'll be living there very happily in your product. So obviously we want to stop that. So preventative methods can be used in the treatment of that flour, whether it be heat treated, or you can use a product called an enterlator to smash the eggs up before the material enters into the downstream process. But very commonly, foreign bodies will come from nuts and bolts falling off processes. When sacks or FIBCs are emptied, there often is paper or string in the process. So there are many things that can be there. And let's have a look at some of the areas. So as I said, fly larvae can grow in the right conditions. So if the materials may be stored in not the driest of conditions, that can accelerate the growth of these things, and then you will find lots of flies in the process. So making sure that you have the product stored in the correct dry conditions is a good start. And as I mentioned before, opening of bags and sacks can lead to shredding of plastic, paper and string, and so we don't want that in the process, so we have to try and remove that from the process. So here is some data that I pulled out looking at the different types of foreign matter you would find in the process. And of course we have this section other. Other can be anything. It can be human hair. It can be bits of animals, all sorts of different things. We can categorize that into any other products because, you know, there are so many different types. What I wanted to look at was the kind of three main areas, which was glass, plastic, and metal. And so this is based around recall contaminants within the EU. So this is from the European Union data. And as you can see, it doesn't differentiate really. Metal, plastic, and glass are all often found in the processes. Okay, so one of the things that the food industry has introduced in more recent years is a thing called hazardous analysis critical control points. I'm certainly no expert on that, but I brought this to the attention because for anybody in a food factory, it's a methodology and evaluation to make sure that your complete process is looked at and that you're doing a complete risk assessment of the process. And there is a lot of information on the internet. I'm certainly no expert, but what I did look at and did find out that there are kind of 12 points to excellence, and there are a wide range of areas that are to be looked at, from critical point control to putting in place a dedicated team, record keeping, corrective actions when you have a problem, obviously flow charts for the plant to work out how things have been done, and of course monitoring of the system as well. So that's one I certainly would recommend people to have a look at. So now I'm going to focus a little bit on the preventative technologies, and I would say I've kind of categorized that into 6 areas that you might consider looking at. Now, some of these, let me just go back again: screening, filtering, opticals, X-rays, metal detection, and magnetics. Okay, so I've categorized these in effectiveness of solutions, kind of just to give a broad feel. I think you can see from here that X-ray is an extremely effective method. It's also a very expensive method, and it's a visual. It doesn't really, it might raise an alarm, but it doesn't actually do anything. It doesn't divert or reject or keep. It's a very complex system, but it also has its limitations, but it's a very effective way. And of course, it's not unexpected that, for example, magnetic use or metal detection is going to have no effect on plastic, glass, or human hair, because for the very nature, they're based around ferrous and non-ferrous materials. And optical, again, a very effective method, other than it could only see what it can see, so it can't see hidden dangers. So if you have, like, we talked about, one of the presenters talked about cakes before. So if you had a filter cake and you had something inside of the filter cake and an optical system was trying to detect it, that would be difficult. An X-ray on the other side would be much more effective at it. So there are obviously things to consider, and of course screening, which is the aspect we'll go into in more detail. Again, it's a pretty effective way, but still has its limitations with certain products and certain types of medias. Okay, so just a broad overview of some of these technologies. Filtering systems, there are many different types of filtering systems. Here I've just highlighted, for example, for the fruit and veg industry, water baths. It's a nice common way of eliminating foreign bodies. You use water in a turbulent fashion. You encourage the fruit and vegetables, which are quite buoyant, to float to the top, and any heavy products such as sediment, so stones and various other products, sink to the bottom and can be separated from the product in that way. Of course, that's great for products that have high resistance to water or moisture, but anything that is absorbent, such as a powder, that would be a non-effective method of separation. Optical inspection, using cameras, more and more. We see cameras everywhere now, of course. Big Brother is always watching, and inside of a factory, it's watching for the right reasons, because it is looking to make sure either things are where they should be, or in some cases where things are but should not be. So it's very effective at spotting. We give an example here of a pizza line. If you have a foreign body there, the cameras can detect the shape of a pepper or a mushroom, and if there's something there that doesn't look right, it can raise a flag. And these systems now can reject, so they can divert the product away. Packaging systems are extremely advanced and very clever, so this is a very effective way of detecting something that is clearly visible. X-ray systems, as we touched on before, very good for seeing what the human eye can't see in this case. So before we had the idea of the cameras looking at it, and in this case we're detecting things that that the eye can't see. Very good for very small particles as well. It's effective for products less than 1 millimeter, and we'll come on to product size a little bit later and why that would be important. And of course, for non-ferrous or ferrous materials, which you can cover in metal detection and magnets, this is very good for products that obviously expand more into plastics and glass. Very good for that. However, still they can't pick up everything, and they're not very good at picking up things like hair, wood, cardboard, paper, insects. So not everything is completely covered by X-ray systems. Metal detection systems. Okay, so the way that a metal detection system is working is it's creating an electromagnetic field, and as a ferrous or non-ferrous piece passes through that field, it stretches the field, and as that disturbance in the field is detected, it then will alert, or in the case of most systems, will create a reject. So as something is passing through, whether it be powder or a solid or even a packet of some kind, if it detects it, it often has a flap system that will divert the product out, and very good at picking up small metal particles, so even metallic powders. It has some of these can have a very high frequency range where they can pick up extremely small particles. And just to give a couple of examples where you might see those, in a process requirement here, we have a picture of a bulk bag filling system. It's quite common to see a metal detector on the in-feed to this type of system to make sure that they can reject it before it goes into the bag. For good reason, because once you have filled 1,000 liters of material, the expression "finding a needle in a haystack" is probably the best way of describing it. In a sack, of course, you have the ability then at the final packaging stage to pass a sack through a metal detection system. So in this case, you can detect that there is something inside of the sack, and maybe 25 kgs of product, one bag being lost because of it, it's not a major disaster. Of course, if you have a full process, you have to think about the previous steps to ensure that you can eliminate the product before it gets into the final packaging. Okay, so magnetics. Magnetics basically using a rare earth magnet. Nowadays, very powerful magnets, extremely powerful. I would always recommend, if you're near one of these industrial magnets, don't wear a watch or have your phone in your pocket, because they might not work very much longer after you're being close to these magnets. They're extremely powerful, and they can take out products now. And I know this is relevant because of the screen media that we use in some of the sieving machines. But typically they can take out wire even down now to around about 300 microns in size, or even smaller. So they're very effective at picking out small particle sizes and small wires in the system. And these magnets can be designed, obviously this is a very hygienic one that you can see in the picture here, designed obviously for the food industry in place. This is a bar magnet where a series of bars and the powder passes through the bars to pick up any larger particles, but also they also do inline systems. So in the powder industry, we saw from the image I showed of the whole plant, pneumatic conveying is a common way of moving powders throughout the factory. It's a fast method. It's not so obtrusive to the factory, but you can actually put a magnet in line. These are called bullet magnets, and very common when you take a road tanker and you're blowing the material from the road tanker into a storage silo. You can have one of the magnets in the system, and of course any potential ferrous and non-ferrous materials can be picked up by the magnet as it passes through. Okay, so screening systems. Typically there are a wide range of different types of screening systems, but the focus that I'm going to put on now is sieving, and that falls into two categories. You can have flat deck sieving, which is in effect a disc, a mesh that the material sits above and is vibrated, or centrifugal sifting, which is on the right hand side, where you are actually creating a centrifugal force to throw the powders to the outside of the sieve. I'm going to focus a little bit on that because that's what we do. So it's my more area of expertise. So how does a centrifugal sifter work? Well, quite simply, you take the material. It comes into the inlet of the system. There is a feed scroll at the inlet side, which gives a level feed of material into the main body. There are a series of paddles. The paddles are spinning anything from a few hundred RPM up to 1,000 RPM, depending on the size of the machine. That's creating a centrifugal force, which is then pushing the powder outwards, throws it outwards, and there is a basket. So this is the basket here, and that basket has the media on it, and that can be a wide range of materials that we'll cover. And the fine particles pass through the basket, and the larger particles travel the length of the basket because they can't go through the mesh, and that is what we call oversized material. You will sometimes see some actual powder in there, and we're looking then to try and maximize the efficiency of that system. But the main purpose mostly of this type of machine is to make sure that you don't have the wrong product going into your process. So you're trying to avoid those things like the paper, the string, the plastic, the glass, all sorts of different products. And it's purely and simply there just to make sure you take that out of the process stream. Okay, so what type of material would you use? Historically, going back a number of years, nylon was always the most common. You can see on the left-hand side, we have some different colored nylon. Originally, it was always just a white nylon, but over time, people obviously realized, well, it's nylon and it could break. So if it does, we want to be able to detect it somewhere downstream. So it was quite common to color the nylons, and people still use lots of nylon material now. It depends on where the process is, but still a very popular method. But in more recent years, obviously metal is more robust, and so we have a woven wire mesh. We also have a material called wedge wire, and quite simply, the wedge wire is, imagine it's a series of metal wedges that are lined up and welded together on a series of rings, and this allows for a very nice product release. So you have a fixed aperture. The aperture on the inside of the basket is narrower than the gaps on the outside because of the wedge shape, and that just helps with product release. So if you have materials that might be a little bit sticky or don't necessarily sort of move through a general perforation too well, that can help with the flow of those materials. And in more recent years, we've seen a big move towards a perforated plate. And the reason for the move to the perforated plate is because it's very robust. Its longevity is superb. It's normally a punched round hole, and we'll come on to aperture in a little bit, and I'll explain why that also is a reason that people have moved towards it. It does have its negativities because it doesn't have as much open area. I think you can see from this picture, if you compare it to the woven wire, there is a lot less open area because by the very nature of punching a hole into a steel plate, you have to keep a gap between the next hole, because if you don't, then you have two holes rather than one hole, or now you just have one big hole, and now you don't have the defined aperture. So that means there is less open area, and less open area means less product going through the same square meter of filter media compared to other products. Okay, so I'm going to talk about the aperture size. There's a link here in the presentation, which hopefully people will be able to see later, or you can search for it. But the statement from the FDA says that as long as a material is less than 7 millimeters in length, they don't consider it to be a risk at all. So okay, so if that's the case, why do none of our customers ask us for a 7 millimeter screen? And the answer to that is because customers don't want foreign bodies in their process. They want to eliminate them. So of course they don't settle for 7 millimeters, even if the FDA says that it potentially is safe. And what they typically are looking for, and this size has come down more and more over the years, is 2 millimeters. But specifically 2 millimeters in any direction. So if you have a square hole on an aperture, and for example, I can give you an example. If you want to achieve 2 millimeters in any direction on a square hole, then you need a 1.4 millimeter aperture size, because the diagonal across is 2 millimeters. And that's why the round hole perforated plate is quite popular, because it's a guaranteed 2 millimeter hole size. so that's it. So now just looking at the different types of material and what are the advantages and the disadvantages. I won't go through every material, but just looking quite simply, I categorize this into efficiency, robustness, and that really is defined. Why is there a difference between robustness and longevity? Because robustness is down to what happens when you have impact against the screen, you know, so how resistant is it to a foreign body coming in? You know, will it resist the actual foreign body and allow the foreign body to travel through, or will it give way and actually break under the impact of the foreign body? And you can see that when we look at things like nylon, obviously it has a low robustness impact. So something sharp like glass or metal, it's a good chance that you might sever the nylon. If you sever the nylon, you lose the principle of screening, and so no longer do you have product which is safe. And then you have to think about how you then either recall the product from within your factory or other processes to ensure that you don't have foreign bodies in the product. Looking at the perforated plate, excellent for robustness, excellent for longevity, excellent for cleaning. But its downside is its open area, as I explained before. So it doesn't get the same rate of throughput. So typically a customer might say to me, I have a flour, I need to add it into a mixer. I want to make sure that I can do that at around about 4,000 kilos an hour. I want to do it through a 2mm screen. So we'll run some trials. And we'll say, yeah, okay, you can do that, but to achieve that same throughput rate, you're going to have to go for a bigger machine because the open area is not so good. So there are different criteria that have to be considered, whereas if that had a wedge wire or a nylon screen, you probably get away with a smaller machine, and you might instead, with the perforated screen, need a machine with probably 30% more capacity to achieve the similar kind of rates. Okay, so where would you typically put a sieve? And this can be a flat deck sieve or a centrifugal sifter. I'm not going to differentiate too much here, but typically at the start of a process. So we're looking at, in this case, a sack tip. So you want to discharge the product from your sack and you want to get it into the process. But there's something you need to think about first, and that's a controlled rate, because this machine does like to have a controlled rate. It works the best if you can control that rate. So a very simplistic way is thinking about a rotary valve. It could be a screw feeder. There are different methods that you could use, but you want something that will dose the material into the machine. And once you have that, you're underway, you're started, and now you can start sieving product. And of course, that can go to any different types of process. And that might be from a big bag, or it might be from a silo. It's very simple gravity process. And what might be going to dryer, for example, or just some kind of pack off, or it might be a mixer, any type of process. Okay, so not only can these units be used in gravity, they can also be used, we call it inline, but in effect it means in conjunction with pneumatic conveying, and that can be done in the case of this system here. I'm going to show you, you have a sack tip and you're going to vacuum that up to a process which might be 5 or 6 meters high because you need to feed into a mixer, but you have to sieve the material first. So where would you put the sifter? In essence, you actually pull the material directly through. So before we showed a gravity feed system, in this case here, we actually suck the product through the main body of the sifter. So you don't have to have 2 separate stages. You don't have to disrupt the conveying system. You can just put it directly in line. And again, rotary valve, something to feed it is always a good system. Okay, again, different processes that can be followed. And in this case, we're looking at a blowing system. So there are a couple of extra things we have to consider here. So again, we put the sifter in place, that's fine, no problem. But one of the things that you might consider in a system like this is, what do you do if you are dropping the product into that same blowing line? So for example, here we're going to show we have some silos and we have a blower that is blowing the material to a further process. And now we're going to introduce a sieve in a gravity form. So back to the same situation, and this is going to drop into the pipe. But one of the things we have to consider is, where will the air that is displaced from the rotary valve underneath the sifter turning? So in effect, if I bring my cursor in here, what happens is, as the air is blowing down the line, of course it's going up here, but it will catch, the air will go into the pockets of the valve and the air will force its way back up. Now, Okay, if that happens, you have an airlock here, that's okay, but the air still has to go somewhere. And if you don't think about the venting of that system, you will have a very inefficient sieving process, because the air will be then fighting against the centrifugal force generated inside of the sifter. So what we do is we quite simply, we extend the hopper, we put a reverse jet filter on the hopper. So we actually, and I think it's shown in a picture later on, we actually allow the displaced air. We have a baffle inside of this hopper, normally runs along the side. If you're looking at it from a front view rather than a side view, and that displaced air then goes into a filter. We have a simple reverse jet just to keep that filter clean. That allows product to discharge downwards through the valve, and any displaced air from the system to pass through the filter, not affecting the sifter in any way. Okay, so just looking at where you might find these sieves, this is just a design system that Erica has built recently for a customer for handling milk powders. And typically, you can see there are big bags of product, so the client's handling big bags and they want to take the milk powder into internal storage for use in their processes. So what we have here is we have two the inline sifters, so the material comes out of the bulk bag systems, and we actually blow the material through the sieves, and then eventually we discharge them into some storage vessels, and eventually we're then discharging a mix of products into the customer's next stage of process. This is an example of a system we've built also recently for an ingredients company. So we have a number of silos and a number of big bag systems. So in this case, we have some gravity sifters at the base of the silo. So as the client calls the material from the silos, they actually sieve the product before it goes into the process. So catching any potential foreign bodies before it even goes downstream. And then just to finish up now, these are just some application pictures so you can see the actual sieves themselves, where they would be. I mentioned before about the displaced air. This is a vent hopper that we use because of the displaced air to make sure that we took away the air from the system before sieving. You can see here we're feeding with a feeder, a screw feeder, which is hand fed. Okay, so last thing, we talked about different types of solutions, so I just wanted to go back and highlight it. So we're going to start with a road tanker. First thing we're going to really recommend here is to put a magnet on the line so we can catch anything potentially coming off the tanker. We might then, I've just highlighted here, we've got general filtration, just obviously to keep the displaced air and to make sure that nothing is coming into the product this way. Here, or again, we might have a magnet, or we might introduce a sieve. Again, at the top here, you might have a further magnet downstream, because don't forget that at the end of the day, while these sieves are designed to remove foreign bodies, as I explained, if you have a material and you drop a spanner into the system, it may damage the screen material, and then you've got to think about, well, you still need some form of secondary protection, so a magnet is a great complement to the product, just in case there's any problems. We've got a guy tipping big bags and tipping sacks, so again, we have a flat deck sieve in the process so that they can sieve from the sack tipping process, or in this case here, we also have a centrifugal sifter shown, so that might be in line. And again, there will be various different places where you will use magnets. So again, looking again at the sack tipping, sieving, magnets. I highlighted here the operator because, of course, we discussed at the very start about making sure that they've got the right type of hairnet and the right apparel when they're in the processing area. And then as we come down to final product, we're thinking about, are we going to use metal detection? Are we going to use X-rays in the system? Okay, so I think that's me done. Hopefully that gives you an overview of the dangers of product contamination and how you can take some very simple steps to try and avoid foreign bodies ending up in the final product in the food industry.
Okay, thank you so much. Amos is having a question. It's a long one. If I'm having issues with food powders moving through sieves in a manufacturing environment, aside from powder size distribution, SEM, and some sort of powder flowability testing, in brackets, Yannick or Brookfield PFT, what else would you consider as a useful starting point? That's question number one. Question number two is, And is the Hausner ratio generally useful as an indicator in powder handling?
Okay, so I'm going to, well, actually, I think the Hausner ratio is not something I'm really aware of, so I'd put that probably back to the guys at Freeman or the Wolfson Centre. Maybe they might be able to be a bit more detailed on that. But I think, of course, you raised some very good, interesting points that in any general powder handling sense, knowing your powder and knowing its performance and how it will work and what measures you need to use to ensure that that powder goes through your process is really important. And of course, all of the points that are raised there are very interesting. I think the other one I would mention is moisture. Moisture it plays a huge factor. Knowing what your moisture content in a powder can be is very important because it adds that extra dimension of what measures do you need to consider. You don't have to change or want to change the moisture content. So, for example, you may have a powder that has a moisture content of 4 or 5%. Just to be clear, my understanding of moisture contents, they can be quite different. So you can have a moisture content that is locked into the particle, so it's natural sort of water, you might say, within the it's not so much water, but moisture within the actual particulate. So when you do a moisture test, you'll get a high reading that way, but on the outside it feels quite dry. And then you can have surface moisture as well, which often leads to a material, if you clump it in your hands, it will hold together, maybe not release so well. So I think moisture is a real key to consider, and really you don't want to change the moisture, but what you can do when you're handling products, powders in a plant, is you can consider things like dehumidification, chilling, using those type of technologies, which when you're conveying, whether it be pneumatically or whether it be through mechanical processes, using that conditioned air, keeping the moisture controlled, keeping the heat down, because friction can be an issue, can cause, obviously, for products. For example, in the discussion about the caking of the milk powders, it was talked about full fat milk. Full fat milk, for example, just like in the chocolate industry and in the formula industry, if you create friction, if you create heat, you can release that fat content. That can cause smearing, that can cause problems. And certainly on a sieve screen, if you're handling full fat milk and you haven't considered the condition of the powder, that can obviously cause the blinding of screens as well. So yeah, that would be my general point there as something else to consider.
Okay, thank you.